Last week I asked you,
leave your entries in the subreddit pros, and I'll watch submissions in the next episode of Why.
Welcome back to yet another live stream. It's been an awful lot of time since the last live stream that I made. Exactly 40 plus days or more. Alright, this time around we are going to be doing something different. We're going to be trying to build a project. We're going to be doing some development. We're going to be pseudo wipe coding a project so that I can have something to show on my resume. I can have something to talk about on my resume. And yeah, besides that, that's pretty much it. I have to do things like this, but otherwise I would end up a homeless person in about 10 months. So if I want the job, I have to do things like this. So yes, welcome to stream number 12. And yeah, let's get started. The idea is this. One moment. Yeah, so this is what I am planning to build. Let me just check whether the stream is working correctly, and we will continue right back. It is. So this is what we are gonna do. We are gonna build something that's useful, at the same time looks impressionable on the portfolio. So the idea is pretty simple. We are gonna build an auto expense/credit tracker for UPI applications, more specifically GPAY, or it's going to work for any of the UPI because we're going to read from emails. So basically the idea is simple. We're going to be, every time you make a transaction to a vendor, you make a payment to the vendor. This is a Gen Z architectural diagram with emojis. So every time you make a GPAY transaction or a UPI transaction to the vendor, you make a payment. This guy, the payment processor, the UPI, GPAY in this case, will send a notification to the bank. The bank will send a mail to you that you have spent, say, 2,000 bucks on Amazon, 2,000 rupees on Amazon. It's going to send an email to you. Every time this happens, so every time this is going to happen, whether it's a credit or a debit, whether you purchase or you send money to somebody else, or you get money from somebody else, or you get your salary credited, this is what is going to happen. When this happens, what we are going to do, or what I want to do, is something a little bit unique, okay? Something a little bit unique, because a bunch of people who make projects on their resume, they will have something like an e-commerce application or something else that's very cliche and that's been done before. I feel like this has not been done before. So yeah, what we are going to do essentially is we are going to take the email, fetch it. We need to figure out a way how to do it. I believe there is something called as an O authentication, OAuth for Gmail API. And then we're going to take that email, parse it on our application, and we are going to display it automatically. So if it's an Amazon purchase, or if it's spent on Flipkart or whatever, we're going to put it under e-commerce. If it's an Ola, Uber, Rapido, or whatever, one of those million ride sharing apps, we're gonna tag it under ride sharing. Or if it's Swiggy, Zomato, Blinkit, or whatever, we're gonna tag it under, put it under food category. This is gonna be done automatically, and our application is also gonna hopefully have things like pie charts, trends, and bar charts and whatnot. Essentially an expense tracker, but the USP, the unique selling point, is the auto fetch from email. So you don't have to manually enter your expenses or credit from someone every single time by opening the app. It's gonna automatically add it. So yeah, that's pretty much it. That's the architectural, Gen Z architectural diagram. And so I would like to preface by saying I have little to no dev experience. It's going to be one hell of a challenge, but we have a long weekend coming up. I have today and Saturday and Sunday and possibly tomorrow as well, where I can just put my head down and work on this project. Hopefully we get it done and deployed by Sunday, or maximum one more week after that. So maximum by October 12th. It's pretty damn late, but it's fine. Yeah, maximum by October 12th. But at least I just want to ship the MVP, deploy the MVP onto Netlify or Vercel by October 5th. So it's today, tomorrow, the day after, and the day after that as well. So 4 days, approximately what, 96 hours? Yeah. Gonna be a bit of a challenge, but yeah. So, as any other startup founder or a college Gen Z student would do, I went ahead and asked ChatGPT for help and perplexity. Not to just give everything that I have to do, but just at least give me to chart out a plan, basically. Because I don't know like what technology to use, right? So it gave me one elaborate plan, and then it also gave me one plan that I can implement within the next 3 to 4 days. Alright, let's just go through it really quick. If it's a mobile app, ideally you would be able to, even fetch messages from your SMS. GPAY does not allow, however, GPAY does not have a API that would allow you to fetch transaction information from the app. So your only option, at least from what I have researched, is to either use fetch from your emails or fetch from your SMS, because this is going to be a web app, a website, because I want to like put things like React.js or HTML and CSS on my resume, Fast API Django on my resume. I decided to go for a web app, and because it's a web app, our only option right now is to use a Gmail API service. So we're going to connect our Gmail and find a way to fetch the info and then parse the info. The thing Sam Altman is basically suggesting is to go with React and White, which is, I believe, is built on top of React. So, and then Tailwind CSS. I believe this module 2. I think this is Recharge.js. And then there is authentication control, deployment, Vercel or Netlify, backend, Fast API. DBMS, you can even use Google Sheets. But yeah, MySQL. And things like security that I really don't care about. So I don't know how many vulnerabilities that I have exposed by live streaming. So I really don't care about security. So anyways, hopefully my employer doesn't hear that. But yeah, got no idea what these are. I know what HTML methods are: get, post, update, patch, and delete are, but I really don't know any of these, man. So I don't want to wipe code 100% of the project, because there is no use if you just wipe code 100% of the project. So the plan is ideally to learn things that are just enough for me to implement that specific concept or technology onto my software, and then build it. And then the bugs that I encounter, I'll just use the internet, Stack Overflow, Reddit, and if I cannot solve it, then I'll just ask GPT or Claude to spit a code. So it's not complete wipe coding, which is just basically prompts and then get the code, paste it on your VS Code. And it's also not pure OG web development, pre 2022, pre ChatGPT. So it's kind of 60-70% raw development, and the rest 40 is wipe coding. That's our plan basically. And yeah, that's pretty much it. I don't know whether do I want to play some music in the background, because the last stream I played a random YouTube video and then the description just showed like 100 copyright songs. So if I do get monetized eventually in the future, that one video is just enough to suck all my revenue. Let me play some rain music. I want to test how this sounds. So mostly it's going to be like this. It's not going to be heavy, but it's going to be, I'm going to be playing an audio in the background. Let me test how it sounds. Alright, how does this sound? Hopefully it's not that annoying, but anyways, I have 0 viewers. The one that you see on top right is just me looking my video using my phone, on my phone. So yeah, does it matter? It doesn't matter. So anyways, let's get started. Before that, let me just bring my charger and then fetch some water. we're back. All this thing is going to be very uncomfortable because it's an unmarked territory, an unexplored territory. It's going to be somewhat anxiety inducing. But hey, let's get into it slowly. So it has just given 3-day plan. So what I asked it to spit out is not just give me. Okay, let's just go. So this is just the overview of how the building is gonna happen. Starting off with we need OAuth and DB first Gmail fetch. So we're gonna create a Google Cloud project, enable Gmail API, OAuth consent. Never used OAuth before. Fast API skeleton. Just heard the term. Don't know what fast API is. MySQL have some knowledge on the queries. Beginner to intermediate knowledge on the queries. Albemic init. No idea what we are initializing. Build auth Google login, build store tokens. Again, Greek and Latin. Then we're gonna parse, normalize, and then insert. Terms I have heard before conceptually. Build the HTML text utility, implement a parcel module, start with generic API, then HDFC, ICICI, SBI, Amazon, Swiggy, Zomato patterns, write normalizer. I think, yeah, this is to feed it into our backend. And then day 3 it says build the UI, basic stats, and deploy. React Tailwind, very easily. It's just given the output, but I've got to learn every single technology that it has mentioned. CORS, no idea what CORS is. Tailwind React, Tailwind only heard of it. React, keep it tiny. React hooks, fast API, UI skeleton. Just simple, this month spend. Just have tables. And then deployment. Testing and QA. I definitely want to implement the category pie and some charts because it would look attractive on my resume. But it has listed it under optional. That's pretty much it. Although this is not the complete roadmap. This is not complete handholding because it's a LLM. It would have skipped a bunch of steps, but it's enough as a North Star, as a lighthouse. It works perfectly. Something that I can use this as the North Star on the sky to know whether I'm going in the right direction. Maybe we skip some of these, maybe we change what's given there, or maybe we do exactly what's there and we just reach our destination. It's gonna be fun, at the same time anxiety driven. I already feel anxious trying to build it, but hey, I need to reconstruct it on my mind, change it into excitement, change the challenge into excitement, and that's pretty much it. Let's get going. Firstly, we're going to be learning what OAuth 2 at the high level. And then we're going to learn fast API at the high level. I don't know whether we need to take notes or not. We're going to be learning a lot of info these 3-4 days. So I guess notes are not required. We don't have the time luxury to do it. One moment. there goes our 25 minutes into just setting up the live stream and explaining what I'm gonna do. So let's just get started. I'm trying to learn, just learn OAuth 2 at the highest level. Most important thing is not to deviate or go off tangent, right? That is the key thing. Music volume, I just looked down my phone, it's a tad bit high. Hopefully this is better. Alright, I know what it is on a high level. I remember reading about it. Basically, you have, let's say you have a Netflix account and you want to share your password, or you have your Gmail and you want to give your Gmail to somebody else. You want to give them the access. So without you giving the password, open what, as far as I remember reading about OAuth, this would access the resource on behalf of that guy. So you guys don't directly communicate with each other, you and your friend, and OAuth will somehow can get the resource without the user one ever sharing his user credential. That is pretty cool. Unbelievable. This guy has made a 2 or 5 minute video. No way, bruv.
That's why we're here today. We're breaking down these complex concepts into digestible explanations. Let's dive right in. Imagine that you wanted banks. Luckily, you wanted access hand over your username and password to another service, and they could access anything they wanted. This practice is frowned upon these days, but we might still encounter this practice in certain personal finance software to scrape information from crusty old banks. Luckily, we have something much better these days. Enter OAuth 2. OAuth 2 is like giving someone a special key. This key allows them to access specific information in another application. We control who gets access to our data without having to share a password. And yes, we can revoke that key at any time. Now let's play this out with an example. Consider a photo storage application, SnapStore. We've been using it to store our photos, and now we want to print some of them using a third-party printing service, PrintMagic. Instead of manually uploading each photo to PrintMagic, we ask PrintMagic to do the job. With a simple click, we grant PrintMagic permission to access our photos on SnapStore. Using OAuth 2, PrintMagic can then access our SnapStore photos on our behalf without ever knowing our SnapStore login credentials. This is an example of the OAuth flow. It's an elegant dance between us, PrintMagic, and SnapStore, all orchestrated by OAuth 2. Now let's unpack this further. In this context, we are the resource owner because we own our photos on SnapStore. SnapStore is the resource server that stores our photos. PrintMagic is the client that wants to access the photos. The authorization server could be a part of SnapStore or an external identity provider and is responsible for handling the OAuth 2 process. Let's follow the OAuth 2 flow in this scenario. It begins when we instruct PrintMagic to fetch photos from SnapStore. PrintMagic sends a client ID and scope OAuth 2. Now let's unpack this further. In this context, we are the resource owner because we own our photos on SnapStore. SnapStore is the resource server that stores our photos. PrintMagic is the client that wants to access the photos. The authorization server could be a part of SnapStore or an external identity provider and is responsible for handling the OAuth 2 process. Let's follow the OAuth2 flow in this scenario. It begins when we instruct PreMagic to fetch photos from SnapStore. PreMagic sends a client ID and scope, which represent the access level requested, to SnapStore's authorization server. As the resource owner process. Let's follow the OAuth2 flow in this scenario. It begins when we instruct PreMagic to fetch photos from SnapStore. PreMagic sends a client ID and scope, which represent the access level requested, to SnapStore's authorization server. As the resource owner, we authenticate directly with SnapStore and grant PreMagic the consent to access our photos. Once photos from SnapStore. PreMagic sends a client ID and scope, which represent the access level requested, to SnapStore's authorization server. As the resource owner, we authenticate directly with SnapStore and grant PreMagic the consent to access our photos. Once fetch photos from SnapStore. PreMagic sends a client ID and scope, which represent the access level requested, to SnapStore's authorization server. As the resource owner, we authenticate directly with SnapStore and grant PreMagic the consent to access our photos. Once consent is granted, the authorization server sends an authorization code back to PreMagic. PreMagic then presents this authorization code, its client ID and client secret, to the authorization server. Now, the client secret is a private key shared only between PreMagic and the authorization server. If the authorization server verifies the authorization code, client ID, and client secret, it issues an access token to PreMagic. Finally, PreMagic uses this access token to request our photos. Once consent is granted, the authorization server sends an authorization code back to PreMagic. PreMagic then presents this authorization code, its client ID, and client secret, to the authorization server. Now, the client secret is a private key shared only between PreMagic and the authorization server. If the authorization server verifies the authorization code, client ID, and client secret, it issues an access token to PreMagic. Finally, PreMagic uses this access token to request our photos from SnapStore's resource server. This OAuth2 process ensures that our SnapStore login credentials are never exposed to PreMagic, while allowing PreMagic to access only the photos we authorized it to see. It's also important to note that the access token can be set to expire after a certain time, or can be revoked by us at any point, providing an additional layer of security. OAuth2 also supports refresh tokens, which can be used to obtain a new access token when the old one expires without requiring our intervention. That's OAuth2 in a nutshell. It's an essential piece of the web. OAuth2 also supports refresh tokens, which can be used to obtain a new access token when the old one expires without requiring our intervention.
Pretty fucking beautiful what OAuth is. If, simple terms, simply put, if I don't have OAuth on my website, nobody is going to use it because it would ask them their own Gmail password, which they will not give. So that's why we need OAuth2. Basically, it's just you giving your valet your key. But instead of giving your actual key to the car, you give another key. So your valet doesn't know your actual key and cannot duplicate the key and cannot access the whole car with the key. Let's say you have two keys. One key will allow you access to the whole car, all the bells and whistles. One key that will only allow you to turn on the ignition and will not allow you to open your bonnet or boot. That key, other key, is OAuth. That is your authentication token or your access token. And the valet has restrictions, right? He cannot access the bonnet, he cannot access the boot. It's pretty fucking cool. I forgot what the diagram is called. I think it's called use case diagram. I just searched up. It's not a use case diagram. Different diagrams in software engineering. UML. Unified Modeling Language. Yeah. Class component. Pretty cool. This one is basically sequence, right? Yeah, sequence UML. Alright, awesome. We need to know that. I've opened up my sticky note where I'm just pasting different things that I need to know. Like after building the project, go back and sort of revisit. Alright, we got the high level info on what OAuth 2 is. Now we need to know what Fast API is. Let's just do a quick web search. Fast API. Fast API is a high performance web framework for building HTTP based server APIs. Now, what is an API? API, as far as I know, is just a programming interface that allows you to communicate. That allows things to communicate. Basically, the front end and back end to communicate and whatnot for building API. So, what is the equivalent of Fast API for Java? Would it be Spring Boot or something? Exactly, it would be Spring Boot. There isn't a direct equivalent, but Spring Boot is generally considered the closest and most widespread for building fast, robust, scalable API. So, because I believe the reason we need Fast API is because we don't have a pre-built API to access it. So, we need to build a fucking API. That sounds very impressive. So what do we need to learn? We need to learn what Fast API is. Routes, requests, and responses. All right. I think the best way to learn would just be to implement it. Like, actually implement it. Kabir Khan of Microsoft. His testimonial is enough. Alright, this is good. The website I'm talking about. Boilerplate. So is this basically Postman? Is Fast API Postman? Is Postman same as Fast API? Consume API. Oh. So we can use Postman to possibly testing, documenting, and collaborating for a user-friendly interface to send request. So okay, that's pretty fucking good. So it's instead of me going to my application and then sending requests, I can use Postman to do the same thing. But test it. Like send specific requests. It's pretty fucking good. It's pretty good. All right, what do we need? Routes, requests, and responses. Get is basically you fetching the resource, post is you creating a resource. Fuck async. Bro, what is this, bro? It's very funny, the AI keeps changing the answers. Routes define how an application handles a request. Okay. So where it takes it. While responses are the content or the data sent back to the client as the result of the request. Beautiful. A route is an URL pattern that maps to a specific piece of application logic, a controller, which then processes the request, generate a response. Like it could be an HTML file or a JavaScript object notation or a status code. Status codes, something that I need to look into as well. So error 404 is one of the popular not found status code. Mapping services path from an origin to a destination. Points, travel information, routes are defined with specific URL path and a HTTP method act as entry points for the application. Directing incoming request to appropriate handler, map to specific functions, business logic. So very interesting. So routes are basically, what do you do when something happens, when an input happens, when somebody clicks a button. Responses are basically what we need to do. What is sent back as a result. This is beautiful. We don't need to know everything deeply, just enough to build it. That's the key. That's the motto. That is how you ship things fast. That is how you learn things fast. That is where a lot of people lack, right? We all just keep learning and then trying to find what is the perfect thing to do. Learn it deeply and then implement. We go the scientist route, the PhD route for everything. The people who win or get the result are those who just implement things quickly, learn just enough and then implement things quickly. Let's watch maybe a couple of videos and then that's it.
the primary jobs of any web framework, including Drupal, is to map URLs that someone types into their browser to the code that will create the content for the page. If you wanted to find new URLs in a module and display custom... One of the primary jobs of any web framework, including Drupal, is to map URLs that someone types into their browser to the code that will create the content for the page. If you wanted to find new URLs in a module and display custom content on the resulting page, or if you want to understand how Drupal modules like Node or User provide their unique URLs, you'll need to understand how to use routes, controllers, and responses. In this tutorial, I'm going to explain what routes, controllers, and responses are. In order to do so, we'll first take a look at how Drupal responds to an HTTP request and where those components are used. Then I'm going to provide a more detailed definition of each term to help with understanding what each component is responsible for and how they all fit together. We're not going to look at code yet. That'll be a future tutorial. The goal here is to get a better understanding of how the system works and how module developers can create new URLs. The short definition is that routes are configuration that Drupal uses to map a URL to
Great definition. Route maps URLs to controllers, which then executes code that returns responses. So valet key analogy to valet key analogy is to OAuth is as to drive through restaurant analogy is to fast API or basically HTTP routes. Routes map URL to controllers, which executes code that returns responses to the client that made the request. Beautiful statement. Valet key. Guess I need to speed things up. Routes, controllers. Maps. Else. Which executes. So clients are us driving through McDonald's. Route is basically the path, the road going around the restaurant. Controllers are the cooks. So you order, you traverse the road. At the end of your road, you stop at the collect pickup point, which they are controllers. So these cooks, the controllers, give you burgers, which are responses that made the request. Do I need to go any further? I believe yes, we need to learn what to get post put.
into too much depth. I think uses to browse HTTP for a page. It starts with the user typing a URL into their browser and hitting enter, directing the browser to request the specified resource. The browser issues an HTTP request, like a GET or a POST, to the URL specified. That request gets sent to the appropriate server. The web server knows how to use Drupal for handling the incoming request and passes control over to Drupal and waits for Drupal to give it back something that it can send back to the browser. Drupal says, I've got this, and then starts the process of returning the request. The incoming request gets sent to the appropriate server. The web server knows how to use Drupal for handling the incoming request and passes control over to Drupal and waits for Drupal to give it back something that it can send back to the browser. Drupal says, I've got this, and then starts the process of returning the request into a response. First, the HTTP kernel is initialized. Its job is to take the incoming request from the server, which is an HTTP request, and turn that into a PHP request object. Basically, a standardized format for representing that array or routing.yml file. Routes also detail. Routes are passed that along to the browser, which can then display the response. And now for a little bit more detail. Routes are defined by modules in a module name.routing.yml file. A module can define any number of routes, each as an entry in the same routing.yml file. Routes also provide Drupal with information about how to parse the URL and extract information from it to pass along to the controller as arguments, and how to do other things like configure access control for the page. Every route consists of a unique identifier, a path that Drupal will use to match against URLs in order to know when to use this route, a controller, which is really the full name of a method on a PHP class that serves as the callback for the route, and additional configuration that provides instructions to Drupal on what it should do when this route is matched. This is enhanced. This gives other code the opportunity to modify the request before
Bruv, nobody talks about basic routes and requests, man. Everybody just wants to. It's just so bad. Okay, I think we need this Medium article. Would suffice. Nobody's talking about what the fuck those are. Everybody's just talking about how to build it. All about HTTP requests and responses. Yada yada yada. What are request and response? Requests. I'll make a request. Someone. Okay. Rudimentary. Client sends a request. Method, resource headers, content, and then server processes it, basically the controller, and then gives back a response. Response can be anything. It could be status codes only, HTML, JSON, and whatnot. Making a request. Now, how to make a request? Application program interface is the intermediary that you use to make a request. Okay, up until the first slash, it is the domain. It is where all the requests will be made. Okay, these are route. This is the route. This thing is a route. It generally tells the server what kind of data you want and how you want it. The server then follows the route, prepares the data to be served according from sender to test RP. You generally use a tool called Postman. Okay, you can try it for free from here. Also, rate my wallpaper. It's pretty fucking sick, isn't it? Isn't this sick? Isn't the wallpaper sick? Postman. And before that, Fast API. I already have Postman up and running. Test our API endpoints. That is how you need to describe it easily. Postman to test our API endpoints. Crisp explanation. Here you can see that we have our data. How long have I been streaming for? Not bad, not bad. Suppose we want to bring the post having an ID of 2. We're going to use a query or a parameter. Using the query, post /2, we only receive this. Beautiful. Using parameters. So we're going to go even more zoomed in. So we're going to go post bracket. Post. It's pretty freaking cool. So post /2 would just give us user ID 2. Another way to do it is parameters. This is a query, this is a parameter. And parameter, you do $ID equal to 2. So you can see that the response in both cases is the same, although the request URL is different. You can apply multiple parameters in a request URL by appending the key value pair with the AND character. Before moving on, let me brief you about headers. Request header is an object that stores the information of the request. Object that stores the info. Okay. Like the content type within the request body, any authorization similarly response will show the push about response. The response header would something look like. Beautiful, man. I think this is pretty much it, right? I guess we can move on to the next topic after going over this. In all the above examples, we observe that the request method is set to get. You may ask, what is a request method? Well, the request methods define the primary action that we are asking the server to perform. Get as well, this must simply gets or brings us the data we want. This is the most simple one of all. If you want to filter the data based on some specific properties, you can add queries or params as shown before. Post, whenever you make a get request, the params get exposed in the URL. Now if you have some sensitive data like password, it might get exposed to someone, so we need to hide the data that we are sending. Here post request comes into play. For a post request, we define body field which contains the data we want to send. And the body remains non-exposed to the session. Okay, how is it happening? I don't understand. Okay, so ideally we can just use get and throw info, but we shouldn't.
request and what happens when I and in the so in this case there's the get form where I get a page and then I pass in this list of parameters. So in this case I'm communicating a piece of information to the server. That piece is key value, so the key is data and the value is 1. The other way to do this is to do it in a post request. So I do a post request, and the other way to do the body of the post request value, so the key is data and the value is 1. The other way to do this is to do it in a post request. So I do a post request, and in the body of the post request, so here the data is in the URL, here the data is in the body of the post request, but fundamentally I'm communicating the same thing to the server in both cases. So what is the difference between these two requests? And there is a quite important difference. The difference has to do with post request. So here the data is in the URL, here the data is in the body of the post request, but fundamentally I'm communicating the same thing to the server in a post request. So I do a post request, and in the body of the post request, so here the data is in the URL, here the data is in the body of the post request, but fundamentally I'm communicating the same thing to the server in both cases. So what is the difference between these two requests? And there is a quite important difference. The difference has to do with the semantics of how the server handles this request and what happens when I make it. You might have noticed that your browser will warn you sometimes if you try to reissue a certain type of web request. Those are post requests. So the browser will notice if you try to issue an identical post request to the server, and frequently a pop-up will show up and says, do you want to repeat this action? Something might happen twice. And so the idea here is that in response to a GET request, the server is going to send you a page. This is a GET request, and the idea is that on some level, nothing changes on the server as a result of this request. So if you level, this is a GET request. The idea here is that in response to a GET request, the server is going to send you a page. This is a GET request, and the idea frequently a pop-up will show up and says, do you want to repeat this action? Something might happen twice. And so the idea here is that in response to a GET request, the server is going to send you a page. This is a GET request, and the idea is that on some level, nothing changes on the server as a result of this request. So if you hit this GET request 10 times in a row, you probably are going to get the same page back. Now, there might be elements of the page that are dynamically rendered that change a little bit, but this value isn't affecting anything on the server. It might be causing the server to send you a particular page, but there's no permanent change to the server state that occurs. So for example, this might be used to retrieve an article on a news site. With the same parameters, I get the same article every time. Okay, so nothing changes in response to a GET request. This is part of the, oh, there's my marker. It's part of the HTTP standard. On the other hand, POST is allowed to change things on the server and frequently used to change things on the server. So this is why POST requests are typically issued by forms. When you click submit on a form, and you click buy, when you click rent, whatever it is, something changes on the server. So for example, if the post is being issued by a shopping site that I'm on, I might end up buying something. And this is one of the reasons you get that warning about not issuing this request twice, because I may not want 2 different copies of the particular Hello Kitty book. I might just want 1. So in other cases, this might create an account. That's another thing that I could do with Post. I might use this to create my GitHub account or an account on a buy, when you click rent, whatever it is, on the server, and frequently used to change things on the server. So this is why POST requests are typically issued by forms. When you click submit on a form, and you click buy, when you click rent, whatever it is, something changes on the server. So for example, if the post is being issued by a shopping site that I'm on, I might end up buying something. And this is one of the reasons you get that warning about not issuing this request twice, because I may not want 2 different copies of the particular Hello Kitty book. I might just want 1. So, you know, in other cases, this might create an account. That's another thing that I could do with Post. I might use this to create my GitHub account or an account on a site. And that's something that happens once. And once I have an account, and then I could use it. Something else you might do is, you know, start the rental period for a movie, right? You rent a movie online. This might start the rental period. And so what changes on the server at that point is that the server is now saying, okay, you have a couple days to watch this movie. There's a little piece of information that's changed. So forms and post requests are allowed to change things on the server. And so something about the world is different after you issue a post request. On the other hand, identical GET requests should produce identical data, and nothing has really changed about the world. So if the request is going to change the world in some ways, if it's going to charge your credit card, create an account, cause something to start to happen, post is what's used for that, and that's the semantics of post. If nothing is going to change, I use the GET request instead. But both these requests can be used to communicate identical requests instead. Post is what's used. If it's going to charge your credit card, create an account, cause something to start to happen, post is what's used for that, and that's the semantics of post. If nothing is going to change, I use the GET request instead. But both these requests can be used to communicate identical data to the server. The differences are just in terms of what happens in the world as a result. Change, I use the GET request instead. But both these requests can be used to communicate identical data to the server. The differences are just in terms of what happens in the world as a result.
Pretty good. That's pretty good. Unbelievably great explanation. Man is teaching everything. What is a Bitcoin? What should the internet become? What is VR? What is AR? Good luck and goodbye. 298 videos and you're leaving us, man. Aaron Schwartz. Remember, good stuff costs money. Did he make the video because his earnings are like too fucking low? This is good. This dude is good. Why did he leave us?
That's it. There's nothing else. We are 100% done. I think it's about video 292, I think it's going to come out to, so about 300. You know, I just like to thank everybody who's involved with this class. We have, you know, one of the reasons that this class works so well is we have a fantastic set of undergraduate teaching assistants. I could try to name all 25 of them, but I think that would probably cause me to go over my 5-minute limit. So I won't do that, but obviously you guys know them and they've been helping you in the activities. And so I hope that you'll sort of share some of your gratitude about anything you might have learned in the class with them. You know, I will say that this has been a lot of fun for me, but it's also been weird. It's been weird because I'm here and you're watching me, but I don't know you. I haven't been able to meet you, and that's been sort of a disappointment for me. And it's a little bit of a sadness about doing a class this way, I've discovered, is that I'm on one side of the camera and you're on the other. And, you know, despite the fact that I have not met very many people in this class, I wish you guys the best of luck at UB. I hope that you've learned something about the types of things that we've told you about. Keep in mind that, you know, these type of concepts are the types of things that you need to see over and over again. A goal here was to give you an introduction to lots of things, and then hopefully a couple of the things that we've thrown out there are going to excite you and inspire you, and you'll continue
This is
to learn
good.
more.
This is
But,
how
you know,
university
again,
classes should be. This is wonderful. Bro, this is good, bro. This is good. This is how classes should be. Anyways, yeah. So where were we? I get it. I get it. I don't think we need to delve deeper. We'll get to know how it works when we actually implement it. But is to update the current data in the database, or I heard that only most people just use get and post. What is the change? Nothing has been done, bro. All right, I'm back. Let's see. Where did we leave? We are looking at HTTP requests, responses, and routes. That's pretty much it. Put this update, basically patch. Patch is basically put with more control. Delete is delete, man. And that's pretty much it. I don't think we need to learn anything anymore. Although let's look at some status codes. Yeah, let's just read this AI slop and then let's just get going. Whoop. HTTP routes, requests, and responses. Describe how clients and service can be together. Routes are specific endpoints in a server. Status codes. Anything that starts with 1 is informational, the request was received, continuing process. 4, anything that starts with 4 is bad. 5 is also bad. 3 is redirectional, further action needs to be taken. Okay, 1 and 2 are just to indicate. 3 is to inform us that more things need to be done. 4 and 5 is to indicate that something bad has happened. Informational, success, redirection, client error, and server error. That's pretty much it, I believe. I think we can learn the rest on the go. Next up, we have basics of his. We do know that. We don't know DDL, DML. And SQL alchemy models. This is something that we need to learn. Okay. Need to learn about SQL alchemy models. First, let's learn what SQL alchemy is. Open source SQL toolkit. ORM. Is this the same as Basically, you use it to interact with SQL. Why though? Python supports OOPs, but it's not an object-oriented programming language. It's a procedural one. I have no idea why we need to use ORDBMS. We can directly just connect. We can directly just connect Python and MySQL together. But hey, if it's a new technology that I can put on my resume, it's pretty good. Fundamentally, it acts as translator. So G translate between scripting and database languages. Question, is everything CRUD? Yeah, when you're an expert in like one specific language, you can just use the extensible just modules and just interact with pretty much any technology. I'm sure there's something that you can use to use Python for AWS or Docker, or even write Java code with Python. There's probably some module or some tool that exists allowing you to do that. Is this Postgres or MySQL? No, it is not a database. Oh, this is interesting. So you don't need. Okay. It's very agnostic. All right. SQL. Let's just glance through a few videos and then let's just see.
SQL Alchemy. It sounds like it's some kind of weird library that combines SQL with questionable practices from the Middle Ages. But that's not true. It's a really cool package that combines the power of SQL with the flexibility of Python. It did get me thinking though, what would my job be if I was born in the Middle Ages? Since I'm Dutch, I would probably be a trader. You know, go to the other side of the world, get all sorts of weird exotic spices, like nutmeg. Or a doctor, which in the Middle Ages basically was somebody killing people for a living and giving the term organ player a whole different meaning. What would your job be in the Middle Ages? Let me know in the comments. Or write it on a scroll and send it to the newsletter. Join rows and tables to objects in Python. And this kind of tool is also a library for working with databases in Python, as this allows you to
like this keyboard.
rows and tables to. SQL Alchemy is a really powerful and flexible library for working with databases in Python, as this allows you to map database rows and tables to objects in Python. And this kind of tool is also called an object relational mapper, or an ORM. SQL Alchemy has lots of tools for working with database and can work with various types of SQL databases, such as SQLite, MySQL, and PostgreSQL. What I'll do today is show you the basics of how it works, but then also show you a couple of more advanced things that you can do with SQL Alchemy. So I'll start with this very first, more functional approach of using SQL Alchemy, so without relying on its class system to map tables to classes. So if you're using this approach, then you're simply using the built-in objects and functions of SQL Alchemy. The first thing that you need to do is create a connection to the database, and that involves a couple of lines of code. In this case, I'm using SQLite. I'm using an in-memory database and not an actual database. That you need to do is create a connection to the database, and that involves a couple of lines of code. Built-in objects and functions of SQL Alchemy. The first thing that you need to do is create.
Nice, man. Wow.
A connection to the database, and that involves a couple of lines of code. In this case, I'm using SQLite. I'm using an in-memory database and not an actual.
What the hell is a SQLite?
All right, this is John, the Gringo CTO. I am in Mexico City and I help a bunch of startups as well as some larger companies with all of their tech needs.
Some phenomenal hairstyle, bro.
In any case, today I wanted to address what may in fact be the most common question that I get about technology, which is what database should I choose? So let's just go through this together. I'm going to try and keep this brief, keep it simple, keep it actionable. Like many things, it's not one of those questions that resolves cleanly to a choose this. It's always the best choice. It's going to depend a little bit, but I'm going to at least try to tease out the things that matter most for making that decision. So first thing is a relational versus a non-relational document data store. So a relational data store, quite simply, is able to model relationships between your data. In almost all cases, you're going to have relationships in your data. Think of it like you have a customer. The customer might have orders. Those orders might have products as well as reference back to the customer. And by virtue of having foreign keys and also having some guarantees, namely ACID, which is an acronym that in very simple terms just means that your data will have some guarantees around making sense, provided that you define it properly. Those are all great things to have in that scenario. And the truth of the matter is, the vast majority of scenarios that you'll find in building any kind of interesting web service are going to have relationships, and therefore they're going to be more of a natural choice for a relational data store. On the other hand, a non-relational data store does not have the capacity to model relationships. So there's something I call the conservation of application complexity. And it's one of those things that sounds too smart, which means I may not have come up with it and I lifted it with somebody else. But in any case, the idea here is that if you want to do anything beyond the it's one of those things that sounds too smart, which means I may not have come up with it and I lifted it with somebody else. But in any case, the conservation of application complexity. And it's one of those things that sounds too smart, which means I may not have come up with it and I lifted it with somebody else. But in any case, the idea here is that if you want to do anything beyond a toy, something of actual interest, there is a minimum of complexity that you can't really drift below. You can move it, but you cannot reduce it necessarily. There is a somebody else, but in any case, the idea here is that if you want to do anything beyond a toy, something of actual interest, there is a minimum of complexity that you can't really drift below. You can move it, but you cannot reduce it necessarily. And so what that means is, in the case of a relational data store, a non-relational data store, you have the responsibility of consistency. If I update a piece of data in one part of my system, I need to make sure that the other part of the system reflects that. The system is not going to do that for me. And it may not sound like a big deal, and maybe it isn't at small scale, but it is absolutely the kind of thing that has killed companies before. So examples of relational databases in one part of my system, I need to make sure that the other part of the system reflects that. The system is not going to consistency. If I update a piece of data in one part of my system, I need to make sure that the other part of the system reflects that. The system is not going to do that for me. And it may not sound like a big deal, and maybe it isn't at small scale, but it is absolutely the kind of thing that has killed companies before. So examples of relational databases, i.e. stuff you should consider using, things like PostgreSQL, things like MySQL, things like SQLite, actually, which I'm going to go into in a little bit more detail. And there are other options too, but those are probably the big three. I'm going to lump MariaDB in with SQLite. It's technically a fork. They have diverged a bit, but yeah, we're basically, for the purposes of what you choose, the same reasoning is pretty much going to apply. Non-relational data stores, just so you're aware and can avoid them for the most part. MongoDB is the classic one. There's some proprietary ones too, like Firebase. I mean, if it wasn't aware and can avoid them for the most part. MongoDB is the classic one. There's some proprietary ones too, like Firebase. I mean, if it wasn't bad enough that you're modeling relational data in a store that can't provide you with relational guarantees, Firebase is a step beyond that and is actually proprietary as well, which means you get to look forward to lovely things like vendor lock-in. And yeah, like I actually have worked, helped a company with their app, and they chose Firebase back, this was probably around 2016, 2017, long before I agreed to help them. And the engineer at the time just didn't know a lot about backend, and to be fair, whatever, 5 years ago, backend was probably harder than it is now, not least because of the deployment story. But yeah, a lot of people just thought, well, hey, like, I'll just go on Firebase. If I ever outgrow it, I'll do a migration. And shock of all shocks, it turns out the migration was harder than anticipated, and they're still on Firebase. And so I've seen a lot of people choose one of these solutions and be happy for a long time. I have very, very rarely seen somebody do something interesting with Firebase and be happy with it. And I've personally been bitten by Mongo many times as well. I've never chosen it deliberately for a project, but I worked for a company and anticipated, and they're still on Firebase. And so I've seen a lot of people choose one of these solutions and be happy for a long time. I have very, very rarely seen somebody do something interesting with Firebase and be happy with it. And I've personally been bitten by Mongo many times as well. I've never chosen it deliberately for a project, but I worked for a company at one point that chose to do their checkout process in MongoDB. That went about as well as you might expect. It's relational data, and also Mongo doesn't provide ACID guarantees, or at least it didn't at the time. And so we were dropping events and things like it was a complete mess. I mean, checkout is one of the strongest use cases for running ACID, and we didn't have it. So that particular error cost quite a bit of money, actually. In any case, these things matter. I would just encourage you to stay within this sort of realm here of relational databases. And as long as you stay here, the chances of you screwing up so badly that it threatens the survival of your startup are relatively low. So the more interesting question, though, is if I'm looking at these three big options, how do I choose between one or the other? And this is how I would approach the decision personally. How do I choose a relational DB? First thing to ask yourself is, a good point I need to talk about SQLite a little bit. So SQLite is differentiated from the other options because it is literally just a file. That's all it is. It's a file that lives in your file system, and that means you can do anything else that you might want to do with a file. Differentiated from the other options because it is literally just a file. That's all it is. It's a file that lives in your file system, and that means you can do anything else that you might want to do with a file. Postgres and MySQL fundamentally are servers, so you deploy them as servers, all of that, and that's fine. They're relatively easy to set up, especially if you have tools and automation and all of those things. But it can come back to just be a little bit more work if you need to migrate one server somewhere else. I mean, the beauty of SQLite is it just quite literally is a file, and you can do anything else that you would normally do with it. You can copy it, you can download it if you want to have your production data locally, whatever you want to do. And so, but the trade-off, of course, is that again, it's just a file, so it has limits. And so we'll get into those trade-offs a little bit later. But the one big thing that is nice is if I needed to deal with a system that was just as lean as possible, and of course if it's embedded or whatever, the fact that I just have another file and that's all I have to worry about, that could actually be a really killer feature. Next question I would ask myself is, am I going to operate the DB myself or my team or what have you? And beyond the question we asked ourselves earlier, if there's my indentation here, do I have an expert operate the database yourself, or somebody on your team, or somebody you're going to keep in-house basically versus outsourced to a service? I think the next thing to consider is whether the database is something that you're going to manage in-house. So ask yourself, am I going to manage the SQL followed by Postgres? On the other hand, if you're going to the winners, I actually put it this way: SQLite, so many things, via extensions and whatever, is or by a managed service. In the case that you're going to manage it yourself, whether that's a bare metal server, VPS, what have you, the inverse of Postgres being able to do so many things via extensions and whatever is also that it tends to be a little bit more complex to operate. And so the winners, I actually put it this way: SQLite, just being a file, is going to be the lowest complexity, followed by MySQL, followed by Postgres. And so on. I almost foreign keys reliably and things like that. So because you're trading off the things that matter most to you as an application. Developer. You don't get the guarantees. You're not able to model a bit further with that stuff, but it's precisely because you're trading off the things that matter most to you as an application developer. You don't get the guarantees. You're not able to model your relations with foreign keys reliably and things like that. So you don't get the guarantees. You're not able to model your relations with foreign keys reliably and things like that. So with that in mind, though, if you want to stay within this relational realm, it's worth thinking, how far can I get with this before I have to switch to something else, and how painful is it going to be to adapt as I go? And so this is probably the most interesting question for something like SQLite. So again, it's just a file, and so you're going to have limits the same as you would with a file. I think the actual theoretical size of a SQLite database is incredibly large, many, many, many terabytes, to the point where it probably wouldn't be a concern, but practically, of course, like it does break down at a certain scale. There's a project called Pocketbase, and they quote, actually, and it's an open source project, you can go try it yourself, but 500,000 users and 10,000 concurrent, because they offer like a subscription event thing for kind of like Firebase, except all modeled relationally. But in any case, those are the kind of numbers that they quote. In that case, it's written in Go, which also has very nice support very nice primitives for concurrency as well. But those kind of numbers are nothing to laugh at, right? And especially if you're able to have a single file that you can do anything with very easily, not have to worry about a second server for your data, anything like that. They quote, in that case, it's written in Go, which also has very nice support, very nice primitives for concurrency as well. But those kind of numbers that all model relationally. But in any server for your data, anything like that. You might actually decide that either these kind of numbers are enough and will last you forever. Which very well might be the case for a line of business app or something like that. Or you might decide, well, look, by the time I have 500,000 users, I'm going to be raking in so much revenue that I can afford to migrate to something else anyway, and for that reason, it's not a problem. I actually am a huge fan of SQLite. At one point in time, it will last you forever, which very well might be the case for a line of business app or something like that. Or you might decide, well, look, by the time I have 500,000 users, I'm going to be raking in so much revenue that I can afford to migrate to something else anyway, and for that reason, it's not a problem. I actually am a huge fan of SQLite. At one point in time, it was not a worthy production choice. Maybe I'll do another video about this at some point. But yeah, for now, I'll just keep it there. I will just say that if you want to get into this, check out Pocketbase. I think it's pocketbase.io, and make sure that you're using reasonable settings. It has something called the write-ahead log. Now, the knock against SQLite a long time ago was that you block your reads anytime you wrote to the database. If you're using wall mode, that's no longer true, and that's how you start getting numbers like this. I'd also suggest that you do script typing. On your columns. It has historically a very flexible behavior around types, very generous, very forgiving. That may not be what you want, actually. So you can make it behave much more like Postgres or MySQL if you turn on script typing, and in many cases, that's exactly what you want. In the case of MySQL or very generous, very forgiving. That may not be what you want, actually. So you can make it behave much more like Postgres or MySQL if you turn on script typing, and in many cases, that's exactly what you want. In the case of MySQL or Postgres, your feature scalability is basically, I don't want to say infinity, but it's practically infinite. If you know how to shard. And sharding is just dividing your single database into multiple databases that you then reconstruct in your application however you need to, if you need to. If you choose every, I don't want to say infinity, but it's practically infinite. if you know how to shard. And sharding is just dividing your single database into multiple databases. That you then reconstruct in your application however you need to, if you need to. If you choose a really good way to shard, the whole point is that you never have to join the shards together. The shard is just an individual server that you're putting part of your data on. And so a little bit more history with MySQL. I do think to be fair, in a vertical scaling setup, I would probably
of using SQL Alchemy. So without relying on its class system to map tables to classes. If you're using this approach, then you're simply using the built-in lots of tools for working with database and can work with various types of SQL. I'll start with this very first, more functional approach of using SQL Alchemy. So without relying on its class system to map tables to classes. If you're using this approach, then you're simply using the built-in objects and functions of SQL Alchemy. The first thing that you need to do is create a connection to the database, and that involves a couple of lines of code. In this case, I'm using SQL I'm using an in-memory database and not an actual database. But you can replace this with any database connection string you have a database running in the cloud, for example. So we first create the database engine, and then we create a connection. Now, of course, normally this is not something you're going to do very often. This will be hidden somewhere in your code. So we first create the database engine, and then we create a connection. Now, of course, normally this is not something you're going to do very often. This will be hidden somewhere in your code, and then you just work with the connection in all the other places, but it's still important that you do that, of course, otherwise there's no way to interact with the database. Another thing that you need to do is create a metadata object. This allows you to define a schema, basically the structure of your database. And then the next thing that you do is create the actual schema of your database. So in this case, we have a single table called database. Another thing you're going to do very often, this will be hidden somewhere in your code, and then you just work with the connection in all the other places, but it's still important that you do that, of course, otherwise there's no way to interact with the database. Another thing that you need to do is create a metadata object. This allows you to define a schema, basically the structure of your database. And then often this will be hidden somewhere in your code, and then you just work with the connection in all the other places, but it's still important. Now, of course, normally this is not something you're going to do very often. This will be hidden somewhere in your code, and then you just work with the connection in all the other places, but it's still important that you do that, of course, otherwise there's no way to interact with the database. Another thing that you need to do is create a metadata object. This allows you to define a schema, basically the structure of your database. And then the next thing that you do is create the actual schema of your database. So in this case, we have a single table. You to define a schema. Important that you do that, of course, otherwise there's no way to interact with the database. Another thing that you need to do is create a metadata object. This allows you to define a schema, basically the structure of your database. And then the next thing, the database. Another thing that you need to do is create a metadata object. This allows you to define a schema, basically the structure of your database. And then the next thing that you do is create the actual schema of your database. So in this case, we have a single table called user. And that table has three columns: an ID, which is an integer, it's also a primary key, and we have a username, which is a string, and an email address, which is SQL databases such as SQLite, MySQL, and PostgreSQL. What I'll do today is show you the basics of how it works, but then also show you a couple of more advanced things that you can do with SQL Alchemy. So I'll start with this very first, more functional approach of using SQL Alchemy, so without relying on its class system to map tables to classes. So if you're using this approach, and you're simply using the built in objects and functions of SQL Alchemy. The first thing that you need to do is create a connection to the database. And in this approach, then you're simply using the built-in objects and functions of SQL Alchemy. The first thing that you need to do is create a connection to the database, and that involves a couple of lines of code. In this case, I'm using SQLite. I'm using an in-memory database and not an actual database. But you can replace this with any database connection string if you have a database running in the cloud, for example. So we first create the database engine, and then we create a connection. Now, of course, normally this is not something you're going to do very often. This will be hidden somewhere in your code, and then you just work with the connection in all the other places, but it's still important that you do that, of course, otherwise there's no way to interact with the database. Another thing that you need to do is create a metadata object. This allows you to define a schema, basically the structure of your database. And then the next thing that you do is create the actual schema of your database. So in this case, we have a single table called user, and that table has three columns: an ID, which is an integer, it's also a primary key, and we have a username, which is a string, and an email address, which is also a string. That's it, single table. If you want to create more tables, you simply add more of these tables That's it, single table. If you want to create more tables, you simply add more of these table objects and then specify the columns that you need. Then, once you have this table object, you can write functions that interact with it. For example, here I have an insert user function that gets a username and an email. And that uses the insert function, insert method on the table, and provides values to the username and email address, and then executes that particular query. So you can have this table object, you can write functions that interact with it. For example, here I have an insert user
break. Well, I'll be taking another break in a while as well. But I don't plan to sleep anytime soon. At least I plan to stay awake up until like 12 or 1. Maybe. I bought a monster so I can just chug on it. And let's see. Let's see when I sleep. And before that, let me just check whether my stream is up and running really quick once again, because this is, I believe, my longest ever live stream up until this point, despite the fact that like 30-40% of the whole way we were just doing nothing. Alright, so SQL Alchemy was what I was looking at. I was also looking at SQLite. I found this really amazing video that teaches you basically how to choose the database for your project, for your startup. And yeah. Alright. So goal for today at least would be to just complete this step 0. Maybe do some of the step 1 as well. I'll get food in about 20 minutes.
And then we create
25 minutes.
Now, of course, normally this is not something you're going to do very often. This will be hidden somewhere in your code, and then you just work with the connection in all the other places. But it's still important that you do that, of course. Otherwise, there's no way to interact with the database. Another thing that you need to do is create a metadata object. This allows you to define a schema, basically the structure of your database. And then the next thing that you do is create the actual schema of your database. So in this case, we have a single table called user. And that table has 3 columns: an ID, which is an integer, it's also a primary key, and we have a username, which is a string, and an email address, which is also a string. That's it, single table. If you want to create more tables, you simply add more of these table objects and then specify the columns that you need. Then, once you have this table object, you can write functions that interact with it. For example, here I have an insert user function that gets a username and an email, and that uses the insert function, insert method on the table, and provides values to the username and email address, and then a username and an email, and that uses the insert function, insert method on the table, and provides values to the username and email address, and then executes that particular query. Then, once you have this table object, you can write functions that interact with it. For example, here I have an insert user function that gets a username and an email, and that uses the insert function, insert method on the table, and provides values to the username and email address, and then executes that particular query. Then, once you have this table object, you can write functions that interact with it. For example, here I have an insert user function that gets a username and an email, and that uses the insert function, insert method on the table, and provides values to the username and email address, and then executes that particular query. So you construct the query, and then you execute it using the connection that we defined right here. Similarly, you can also have a select user, so we have a username that we pass as an argument, and we return a result. Just like the insert operation, we create a query, which is a select query, and we provide a condition, which is that the username in the table is the same as the username connection that we defined right here. Similarly, you can also have a select user, so we have a username that we pass as an argument, and we return a result. Just like the insert operation, we create a query, which is a select query, and we provide a condition, which is that the username in the table is the same as the username that we passed as an argument. We retrieve the result back to the query, and then we fetch one of the results, and that's going to give us the user. And then in the main function, we call create all. We supply the engines. So this is going to create the tables that are necessary, and then we can call the functions that we define. So insert user, select user. So when I run this, then this is what we get. We get one user that's been inserted with ID 1, and this is what's being shown when I print that particular user. You can also tell SQL Alchemy to print a bit more details, but we supply the engines. So this is going to create the tables that are necessary, and then we can call the functions that we define. So insert user, select user. So when I run this, then this is what we get. We get one user that's been inserted with ID 1, and this is can call the functions that we define. So insert user, select user. So when I run this, then this is what we get. We get one user that's been inserted with ID 1, and this is what's being shown when I print that particular user. Integer, username, and an email, and ID is a primary key. Details about what it's actually doing by setting echo to true when you create the engine like so. And now when I run this code again, you see that we get more details. So the first thing that it does is creates a table which has an ID, integer, username, and an email, and ID is a primary key. And then you can also see what, for example, the insert operation looks like or what the select operation looks like. So this is really helpful for debugging. So you can then analyze the queries and see whether you're really querying the database in the way that you want to. Now this is a very simple, basic way of using SQL Alchemy, but this will typically not be how you use it, because SQL Alchemy has very powerful mechanisms to tie into Python's object-oriented programming to allow for a lot more flexibility. And so here you see another version of this exact same example. We have a single user table, but now I'm using an object-oriented approach. So the way that this works is that, well, we still need to create the database engine because that's underlying everything. But then we create a session using the session maker function that binds the database to the session. And then we create a base. And this is the base class that you will use to define actual tables. And in the main function, you see that base has metadata. So that's the object that's the database engine because that's underlying everything. But then we create a session using the session maker function that binds the database to the session. And then we create a base. And this is the base class that you will use to define actual tables. And in the main function, you see that base has metadata. So that's the object that manages the schema for us. And there we pass the database in order to create the actual schema. So we use the base object. But now that we have this, we can define classes that inherit from base. So here, for example, we have a user class that inherits from base. We supply a table name with a yonder instance variable called, so the table is called users. And then we use a data classes like mechanism of defining the column. So instead of having to call the column functions, we can simply use the types, which is a really neat feature of SQL Alchemy. And in order to specify the types of the columns, we use the mapped type. So IDs, mapped integer, username, and email are mapped strings. And then you can call optionally the mapped column function to supply when you define what the column is supposed to be like. But the nice thing is now that we have classes for each table, we can add methods to it. For example, here I've defined the wrapper method, which gives us a developer-friendly representation of the object. In this case, that's user with an ID, username, and email address. And if you wanted to, you can add more methods to the user table here that work with this particular data that's part of each row. And the way that you work with data now is very simple. So we can simply create an instance of the user class that we just defined here, and then we can use a session to actually interact with the database. So we use the session class that's been generated by Session Maker, and then we create a session instance that we can then use. So in this case, we add the user to the database, and then we commit that. And of course, here I'm just adding a single user, but you can add as many users as you want, and then commit that result. And once you have that, there's also easy mechanisms to query the database. For example, here I'm querying the user table, and I simply want to get all users. And then that's going to print all the users that are currently in the database. So when I run this particular example, we see that we now get the single user that we just used. Here I have another version of the user table, but I've added a bit of complication here. So we don't just have a user name and email address. We now have, next to the ID, we have an auth object, and we have a posts object. So user has a user auth. What that is, I'll show you in a minute. And it also has post. And as you can see, a major difference here is that auth user has a user auth. What that is, I'll show you in a minute. And it also has post object, and we have a posts object. So user has a user auth. What that is, I'll show you in a minute. And it also has post. And as you can see, a major difference here is that auth is not a mapped column, but it's a relationship. And it's a relationship between user and user auth, which is defined below, which is also a table in the database. And this is what we call a one-to-one relationship. One user has exactly one user auth. There's also post, which is a mapped list of user posts. So that's a one-to-many relationship. A user can have many posts. And then user auth contains information related to a specific authentication method. In this case, that's a hashed password. Now, this is, of course, a very basic authentication example, and you wouldn't typically develop all this yourself from scratch, especially if you're using, for example, many relationship. A user can have many posts. And then user auth contains information related to a specific authentication method. In this case, that's a hashed password. Now, this is, of course, a very basic authentication example, and you wouldn't typically develop all this yourself from scratch, especially if you're using, for example, something like Fast API. It's going to have already things like authentication or OAuth flows implemented, so you can use those as a starting point. But of course, you still need to store authentication data in the database. Now, next to authentication, another thing you might want to do another version of the user table, but I've added a bit of complication here. So we don't just have a user name and email address. We now have, next to the ID, we have an auth object and we have a posts object. So a user has a user auth. What that is, I'll show you in a minute. And it also has posts. And as you can see, a major difference here is that auth is not a mapped column, but it's a relationship. And it's a relationship between user and user auth, which is defined below, which is also a table in the database. And this is what we call a one-to-one relationship. One user has exactly one user auth. There's also post, which is a mapped list of user posts. So that's a one-to-many relationship. A user can have many posts. And then user auth contains information related to a specific authentication method. In this case, that's a hashed password. Now, this is, of course, a very basic authentication example, and you wouldn't typically develop all of this yourself from scratch, especially if you're using, for example, something like developers to build fine-grained custom roles and permissions into your applications. It uses a special language for that called Polar. Polar has out-of-the-box primitive support, access control mechanisms,
Alright, I'm back. This time around with a monster as my buddy. So we'll attempt to stay awake until 1 or 2 a.m. tonight. I'm a bit on time crunch actually, from the campus drive perspective, so I need to do stunts like this every once in a while to get ahead. Alright, let's get going. Last time, only like less than 50% of the time has been utilized for productive focus. But this time around, between the time now until 1 or 2 a.m., I'll try to focus even more with even more intent.
When you have been using Python for a while, you might have already noticed that there are quite some instances when a Python virtual environment is the way to go. In VS Code, let's get started right away. So I'm gonna start with creating a folder. So click on File, Open Folder. Just navigate to the directory where you want to save all the files for this course. In my case, I created a directory on my OneDrive which is called Python scripts. And here I'm going to create a new folder. It's called Selenium course. Click on that folder after you've created it. And then we're going to create all the files and as well the virtual environment. First of all, I'm going to create a new file and I'm going to call that file main.p1 hello world, but you also see programs Python, Python 3.11, Python.exe. Hello. I'm just going to say here print hello world. Let's run the script. Used is in app data local programs Python, Python 3.11, Python.exe. And this is what we call the global Python environment, and that's the Python version that's currently installed on your computer. If we don't want to go with this Python version, we want to create a virtual environment. So I'm just going to put my cursor here and then type Python -m venv dot venv like this, and then press enter. You see now that a new folder is created, and this is the folder where your virtual environment is being saved. VS Code also asks you, you notice a new environment has been created, do you want to select it for the workspace folder? And you want to do this, so click on yes. And maybe you've noticed that at the bottom of the screen, this just changed. So if you click here, you can select the Python version that you want to use. So as you can see here, there is a global Python version, which is Python 3 workspace folder, and you want to do just changed. So if you Python version, we just recommend it. So you see here global, and the recommended one is the one in the virtual environment. So I'm going to go with the one in the virtual environment. So I'm still going to select this. If you want, you can always change it here. And if I navigate to .venv and I expand it, and I navigate to the lib, this is where all the packages are installed. So you see currently pip is installed, and there is another pip version installed, and there are some other tools installed, but there is no library called Selenium here. So let's try the following: pip install Selenium. You don't have to follow this, I just want to show you how this works. So I'm going to press enter. And now the weird thing that happens is that we get here the message requirement already is satisfied. And then you see here that Selenium has already been installed in this library, but you don't see it here. And they are not included in this project if they are installed in a global Python environment. So there is one thing that we still have to do, and that's we have to activate our virtual environment. And if we do that, all our packages will be installed in the virtual environment instead of in the global environment. In order to do that, I'm going to type .venv /scripts/activate. Press enter. Now you see in my case, Python just changed to the virtual environment because you see here .venv. But it's very possible that you get an error, and if you get this error, the only thing that you have to do is you have to copy this code. So you have to change the execution policy, press enter, and if you've done that, you're gonna again execute this script. And now we have activated the virtual environment. So if you get this .venv here, you can be sure that your virtual environment is working as expected. And if I now run this command, pip install Selenium, and press enter, you see in this case I don't get requirement already satisfied. I see that a whole bunch of libraries, which are all dependencies of Selenium, have now been installed here. So we can now close the terminal. If you need a terminal again, just click here on terminal, new terminal.
What is a virtual environment? Well, this is simply a self-contained location that enables you to maintain separate and isolated environments for your Python projects. This isolation lets you manage dependencies, versions, and packages without conflicts across different projects. When you work on multiple Python projects, it's likely that some of them depend on different versions of external libraries. isolated environments for your Python projects. This isolation to maintain separate and isolated environments for your Python projects. This isolation lets you manage dependencies, versions, and packages. What is a virtual environment? Well, this is simply a self-contained location that enables you to maintain separate and isolated environments for your Python projects. This isolation lets you manage dependencies, versions, and packages without conflicts across different projects. When you work on multiple Python projects, it's likely that some of them depend on. So to begin, you need to open up a terminal or a command prompt. If you're on Mac or Linux, open up your terminal. If you're on Windows, open up command prompt or a PowerShell instance. From here, we're going to navigate into the directory where we want to create a new virtual environment. It's worth noting that virtual environments are simply directories on your system, so you want to put them in a place that's logical, like the location of the Python project that requires this environment. In my case, you can see that I'm in the example directory, which is on my desktop. So simply go to a directory where you want to create your virtual environment. From here, we're going to create a new environment using the built-in venv command or venv. Now, it's worth noting that there are other tools that can do this, like conda, virtual env, pipenv, and poetry, but venv is built into Python and it's the most common one. Now, the commands for creating and activating a virtual environment are slightly different from Mac or Windows, but I'll run through both sets. So if you're on Windows, you're going to use this command, which is python -m venv, and then env. Now, the env part here at the end is the name of the environment. You can name this anything that you like, but it's convention to name it env. Now, if you're on Mac or Linux, you'll simply change the command to be python 3. So in my case, I'm on Mac, so I'm going to run python 3 -m venv. Python -m venv, and then env. Now, the env part here at the end is the name for the environment. You can name this anything that you like, but it's convention to name it env. Now, if you're on Mac or Linux, you'll simply change the command to be python 3. So in my case, I'm on Mac, so I'm going to run python 3 -m but it's convention to name it env. Now, if you're on Mac or Linux, you'll simply change the command to be python 3. So in my case, I'm on Mac, so I'm going to run python 3 -m venv. Now, at this point, it will create a new directory for us. So if we type ls, you'll see that we have the environment env in this directory. Now, what we need to do is activate the virtual environment, and to do that, again, the command will be slightly different depending if you're on Mac or Windows. If you're on Windows, you're going to run the following command. Now, the command is this, the name of your environment, which in this case is env/scripts/activate.bat. Now, for some reason that doesn't work, you can try just /activate, so remove that bat extension. Now, if you're on Mac or Linux, the command is a little bit different. This is going to be source env/bin/activate, so remove that bat extension. Now, if you're on Mac or Linux, the command is a little bit different. This is going to be source env/bin, and then /activate like that. Now, once you've activated the environment, you should see that you get a prefix with the name of the environment appearing before the normal line in your terminal. So whether you're on Mac, Windows, or Linux, you'll know this is working once you see the parenthesized version of your environment name before your main terminal line. Now that we're here, I'll show you how we deactivate the environment. So to go back into our global Python installation, to do that, you simply type deactivate. The command will be the same whether you're on Mac, appearing before the normal line in your terminal. So whether you're on Mac, Windows, go back into our global Python installation. To do that, you simply type deactivate. The command will be the same whether you're on Mac, Windows, or Linux. Then we can reactivate by using this environment with into our global Python installation. To do that, you simply type deactivate. The command will be the same whether you're on Mac, Windows, or Linux. Then we can reactivate by using the source command again, or the activate script that I showed you on Windows. So now that the environment is created and activated, we can go ahead and install some packages into it. Now, to do this, we're going to use the pip command, which stands for the preferred installer program, or the recursive acronym, which is pip installs packages. Now, if we want to view the packages that are in the current environment, we can start by typing pip list. That will show us that we can actually upgrade pip if we'd like to. We don't need to do that right now. We can see that we just have 2 packages, pip and setup tools. The reason we don't see any other one is we're in the virtual environment now, not in our global version of Python. If we were to deactivate this and run the command again, we can see any packages in our global environment, but here we're in virtual. Now that we've done that, we can install a package. So one some of us have probably used before is the request package. So let's go pip install request. When we do that, it should install everything. And if we type pip list, you'll see now that we get all the dependencies for request as well as the request package itself. You'll notice now if I deactivate the environment and I type pip list, I can see pip 3 here, I'll get a huge long list of a bunch of other packages that are installed globally. Whereas if I go back into the environment here and I type pip list, we should see the ones that are part of this environment. So now at this point, let's imagine we've done some intense Python development and we're ready to push this to GitHub or share a project with someone else. Now, in order for them to run this code, they'll likely need the same requirements as us. Now, rather than exporting our entire environment, we can simply save a list of all the dependencies we used into a requirements.txt file. Now, to do that, we're going to use the following command, which is pip freeze. We're going to use the greater than sign, and then we're going to type requirements.txt if I spell that correctly. And what this will do is take the output of pip freeze, which gives us all of the different packages and their version, and save it in this file. So when I do that and I type ls, you'll see that now we get a requirements.txt file. If we have a look at requirements.txt, it has the output of pip list that we looked at before. Now let's get out of this here, and let's see how we could use the requirements.txt file to actually install these various packages. So let's imagine we're someone else, we've now got access to this code, we want to start working in it, and we have requirements.txt file. Well, first we'll make sure that we're out of this environment, but we'll probably end up creating a new. So we'll start again, and we'll type commands, in this case python 3, python venv, we'll just call this my_env. We'll create a new environment, so we'll then activate it, so this will be source, and then my_env/bin/activate. Again, on Windows, this is going to be a different command for activation. Now we're inside of this environment, this is a new environment, and you'll notice that now we have env, my_env, and requirements.txt. If I pip list inside of here, you'll see that we don't have those requirements, so the request module that we need, but we can install them using this requirements.txt file. If I pip list inside of here, you'll see that we don't have those requirements, the request module that we need, but we can install them using this requirements.txt file. To do that, we very simply just type pip install -r and then requirements.txt. The -r stands for install from a file, so we specify the file name, which is requirements.txt. And now what pip will do is read this file, requirements.txt. The -r stands for install from a file, so we specify the file name, which is requirements.txt. And now what pip will do is read this file, find all the requirements, and install it in this environment. So when I hit enter here, it's going to go ahead and install that. And now if we type pip list, you'll see we get a list of all of the different packages that work from our requirements.txt file. So this is very common practice. You'll actually download a Python project, you'll see a requirements.txt file. What's expected from that point forward is you're going to create a new virtual environment, you're going to activate it, you're then going to install all of the different packages using the requirements.txt file. Again, that command is pip install -r requirements.txt. Now at this point, you've learned how to create an environment, activate it, install.
I'm just going to try and experiment with virtual environments, and let's see. Discord. Beautiful. Oh my god, man. All of these are globally installed. So basically, We're just trying to we're just practicing how to create virtual environments, how to create the requirements.txt and how to use requirements.txt. So let's just go to our new environment over here, my env, and open up pip list. It should be empty except pip, and we will install pip install recursive require. This should install. Beautiful. It's also very quickly. It is installed very quickly for some reason. I don't know how. Nice. So I'll just deactivate. Now let's just delete all of this from our. Also delete our virtual environment, original virtual environment that we created. Delete our requirements.txt. That's pretty much it. need to learn how to create React and white pages. But so we can do that. Surprising, VITE is pronounced as wheat.
Discord
their corresponding properties inside of person. Now, this is really nice. You use this a lot, especially when you're working with prompts, which I React tutorial. This is a JavaScript tutorial for people who want to learn React or are learning React, but it is very useful for that, and you'll find yourself using this a lot. And another thing that this corresponds to that is important to learn is basically whenever you have an object like this, where it's called person, and you already have a variable, for example, name, which is equal to Pedro, and you basically want to set this object to have the value name equal to this variable you have over here at the top, right? So this is very common. I have this variable called name, and I'm creating an object called person, which its name key has the same value as the name variable. Well, you could do something like this and set name equal to name, but there's the shorthand notation, which is really nice, and I would definitely recommend you doing this, which is when the key of this key value pair has the same name as the variable you're setting it equal to, you don't have to repeat the variable name. You can just do this, and this when you're working with arrays. guys to at least know. And that's basically it for everything that I feel like you need to know in JavaScript before going into React. Now, I know that I assumed that you guys knew the basic of JavaScript before this, and the reason for that is because yes, you're not required to know